Jai Hind everyone. Today I am going to discuss about the rectifier, which is a very important topic of power electronics. So basically the rectifier is of two types, single phase rectifier and it's a half wave rectifier. Okay, single phase rectifier. On the basis of input supply, I am telling you the two types of the rectifier, that is single phase rectifier and the three phase rectifier. Again, the single phase rectifier is divided into two parts, you can say half wave rectifier and full wave rectifier. So in today's lecture, I am going to discuss the half wave rectifier for different loads. So first of all, I will give the introduction about the rectifier. What is the phase control of the rectifier, and then we'll start with the single phase half wave rectifier for various load. First we'll discuss about the R load, then if we RL load, if you put the RL load, what will be the output voltage and the output current, and what will be the expressions for the output average voltage, RMS current and RMS output average output current. All these expressions will also be discussed in this lecture, and if time permits, then I'll discuss the single phase half wave rectifier for RL load with the freewheeling diode. Okay, so when I'll discuss this topic, then only I'll tell about the freewheeling diode. So starting with the introduction. So basically, what is phase control of the SCR? It means having the control on the phase relationship between the start of the current through the SCR and the source voltage, right? So basically, when we are talking about the phase angle, we generally mean that the angle of a sinusoidal quantity at any particular instant of time, right? So basically, the phase control means that the phase angle where the SCR with respect to the source voltage is getting turned on with the application of the gate signal, right? So with the help of this diagram, I'll explain you in a much better way. So here you can see that a thyristor is connected for the load R with the input supply Vm sin omega t. Okay, so this is the single phase supply, right? It is having the two positive half supply and the negative half supply for this, right? This is the single phase supply. We have positive cycle and the negative cycle for this supply, right? So during the positive half cycle, if we talk about the positive half supply of the supply voltage, half cycle of the supply voltage, we can see that the thyristor will get forward bias because it positive will come here, right? And during the negative half cycle of the supply voltage, thyristor will get reverse bias, right? So when thyristor get forward bias and will apply the gate signal will apply the triggering pulses, will provide the pulse to the gate signal, it will get turned on, right? So the instant from where the thyristor get forward bias to the instant where thyristor actually get turned on will be called as the firing angle, that is represented by the alpha. So you can see during the positive half supply cycle of the supply voltage, thyristor is forward bias, and if thyristor T is fired, it will get turned on. Means if it is getting the cycle, that is it is getting the firing pulses at the gate terminal of the SCR, it will get turned on, right? So from here to here, thyristor is forward bias, but at an angle alpha, here it will get the firing pulses, and at once the output voltage switches to the supply voltage, and this will be the output of the for the R load, right? So load is resistive in nature, so our load voltage and the load current will also follow the supply voltage, right? Now if you can see the waveforms here. For the positive half cycle of the supply, when thyristor is forward bias, it will at once follow the positive supply, right? And during the negative half of the cycle of the supply, thyristor get reverse bias and it will get turned off. So we will get no voltage at the output. Okay, and after 2 pi, cycle is again repeated, right? So the time period you can say is 1 by 2 pi. Time period is actually 2 pi. For V naught average, we have to put the formula 1 upon time period, and the integration from alpha to pi, as it is conducting from alpha to pi, Vm sin omega t, right. So here you can see after 2 pi the cycle is repeating. Since the load is resistive in nature, so the value of the input current will, the wave shape of the input current will remain same as the V naught, but the magnitude is different from V naught here. Here the magnitude, this is Vm sin omega t, and this will be Vm by R, the magnitude is. And again in the negative half cycle, since thyristor is not conducting, there will be no current at the load, so output current will be equals to 0 here. So by having a phase control of SCR, we can have a control on the output, or you can say at the load voltage. That is why it is known as the phase control. Let's say that thyristor, if we assume that the thyristor is triggered at an angle alpha, that is which is equals to 0, right. So the average load would have been the maximum, as SCR will get turned on from 0 to pi. Similarly, if firing angle is pi, so average load will be 0, average load voltage will be 0, because at pi SCR will get reverse bias, and it is getting the firing pulses at pi, so there will so it will not be of any use and will get the output voltage equals to 0, because SCR will not conduct as it is reverse bias. Okay. So this is the basic of the phase control. Now I will start discussing the half wave rectifier for R load and then RL load, and one by one. So first of all, for R load, single phase, since we have single phase, so I'll apply the single phase supply here, and it is half wave rectifier. So again I am putting a single thyristor here for R load. So we have a load at R here. So this is the R load here. This is the thyristor. So you can say here, let's say this thyristor, the supply voltage is Vs here. Okay. So we can, this is Vs, this is the supply voltage, and this will be the wave shape for V naught here, the I naught wave shape, and I also make the wave shape for the voltage across the thyristor. Okay. So as I have already told you that for thyristor to be in turn on state, it must be forward bias first of all, then it must have the firing pulses at the gate terminal. So let's say that at an angle alpha, thyristor is getting the firing pulses, right. So here you can see during the positive cycle of the supply, thyristor will get forward biased, right, and let's say at an angle alpha, it is getting trigger pulses at its gate terminal. So the load voltage at once will become equals to the supply voltage, and we will be having the supply voltage till pi, right. At pi the cycle is reverse, here minus plus, so thyristor will get forward reverse bias, and there will be no output voltage at the load terminal, as it behaves like an open circuit, as it behaves like an open switch. Okay. So at open switch there will be no voltage and no current, right. And again at 2 pi plus alpha, when thyristor is again getting the firing pulse, it will again get turned on and turned off in the reverse, in the negative supply cycle of the supply. Since the load is resistive in nature, value of the load current will also be same as that of voltage. Okay. This is 0 and the magnitude is Vm by R. Okay. Now thyristor voltage. So when thyristor is turned on, the duration in which thyristor is turned on means it is behaving like a closed switch. So since it is closed switch, there will be no voltage across it. From alpha to pi, there will be no voltage across the thyristor, right. but during the negative half cycle it behave like an open switch, and the voltage input supply will appear across this open switch. So this will be the voltage till pi, right? And from again to pi to alpha, thyristor is behaving as a open switch, right? So again we can trace the input supply voltage like this, and here it is conducting, so voltage is 0, and for negative cycle again we can trace this. So from, you can see, from 0 to alpha what will be the voltage, since it is repeating in nature after 2 pi, तो हम यहाँ से trace कर सकते हैं from here to here the supply voltages, the thyristor voltage across the thyristor will be Vs, which is equals to Vm sin omega t, right? So this is the values, and now we have to, if we have to find out the value average voltage across the thyristor, then it will be 1 upon time period. So time period will be, for this cycle will be 2 pi, as after this cycle is repeating. So 1 upon 2 pi integration from where to where, from alpha to pi, as thyristor is conducting only from alpha to pi, and this is Vm sin omega t d omega t. Okay, after solving it we will be getting Vm upon 2 pi, and this will be cos omega t from alpha to pi, and sine, in sine this is minus, so this is cos pi is 1 sin 90, okay, 1 plus cos alpha, it is coming out to be V average will be Vm upon 2 pi 1 plus cos alpha will be the average output voltage for this circuit, right? And similarly average output current for this circuit will be, I will write with another pen, I naught average. If we talk about the I naught average, so let's do it on another page. I naught average will be V naught average by R. So I naught average will be equals to Vm upon 2 pi R 1 plus cos alpha. Okay. Now V naught RMS will be, for this circuit, 1 upon 2 pi alpha से pi तक का था Vm square sin square omega t d omega t will be the raised to the power 1 by 2, right? So this will be the value of the V naught RMS. If we solve it out, then you can see here Vm square upon 2 pi, and from alpha to pi, and sin square omega t can be written as 1 minus cos 2 omega t, okay? And after solving this, we'll be getting the value of V naught RMS equals to Vm upon 2 root pi minus alpha plus 1 by 2 sin 2i's of alpha raised to the power 1 by 2. So this will be the value of I naught RMS, V naught RMS, and I naught RMS will be V naught RMS upon R for this case. Okay, power delivered here will be V naught will be equals to V naught RMS into I naught RMS. Okay, so now coming for the RL load. So single phase supply के लिए for RL load, this we are using here the one thyristor and RL at the load, and input पे we have Vs, which is equals to Vm sin omega t. Let's say plus minus, and this will be the voltage across the thyristor. This is the load here, okay, and this is I naught, and this will be the value of the V naught. So again, let me draw the voltages. Sorry, let me draw the waveforms. Vs, which is equals to here V naught, and for RL load this will be the value of the I naught, and I'll also draw the waveform for the Vt. Okay, So again here, during the positive half cycle of the supply, thyristor will be forward bias, and during the negative half cycle of the supply, thyristor will be reverse bias, right? So this is understood. Now thyristor will get triggered, means turn on, as soon as it is getting the supply. As soon as gate is getting the pulses, right? So you can see here, let's say for the positive, let's talk about the forward cycle. Let's talk about, start from the alpha. Okay, during the positive half cycle, thyristor is forward bias, right? At an angle alpha, the gate is given the firing pulses, and thyristor will get turned on, and the current will flow in the circuit like this. Okay, so we'll get the voltage output like this, and because of the inductive load, the current slowly rises and reaches to the peak value at omega t is equals to pi. Okay, here all the waveforms are with respect to omega t. Okay, now what happened when the current reaches peak value, and during the negative half cycle, thyristor tries to thyristor is reverse bias, but due to this inductance, energy is stored in this inductance, and it will oppose the flow of change of current. Instantaneous change of current will be opposed by the inductor in the load, right? So it will keep the thyristor in the on position until the energy stored in the inductor is released. Let's say at point beta, the current across the total energy across the inductor will get released, and the current will become 0, and now the output voltage will also become 0. So thyristor will continue conducting from pi to beta because of the inductance L in the load, as it opposes the instantaneous change in the flow of current. As soon as the energy is released in the thyristor, in the inductor, right, thyristor will get turned off, as it is already reverse bias at omega t is equals to pi, right? And from beta to, again let's say 2 pi, there is no conduction, and similarly after this the cycle repeats, right? So from again 2 pi plus alpha, thyristor again start conducting till next beta, and the cycle repeats. So there is no conduction, right? And the current is again from here to here, okay, and then value is 0. Now whenever thyristor is conducting, voltage across it will be 0, and when it is not conducting, it will continue to have the supply voltage. So from here, this will be the voltage across the thyristor. This is 0, please. Okay, again it is like this. Magnitude is same, Vm sin omega t. Okay, so you can see here, from here alpha to beta, thyristor is conducting here from alpha to beta. Beta is the extinction angle, okay, and alpha is the firing angle, and beta minus alpha will be the conduction angle, right? This is the conduction angle. So we can write here V naught average will be equals to, again the time period here is 1 upon 2 pi, and conduction will be now from alpha to beta, Vm sin omega t and d omega t. So this will be Vm upon 2 pi, and this is, sorry, cos omega t माइनस के, और ये अल्फा टू बीटा है, तो ये सॉल्व करके आएगा cos अल्फा, if we solve it, V naught average will be equal to Vm upon 2 pi, this will be cos alpha minus k cos beta, and you can say I naught average will be Vm upon 2 pi r cos alpha minus k cos beta. Now in this case we have two components of the output current. One is the transient and another one is the steady state current. So here I am going to find out the value of I naught RMS, and V naught RMS is same as the V naught average. No, exactly not same. You have to find out the V naught RMS using the formula from the V naught average. Keep the bracket here, put 1 by 2 here and make Vm square, Vm as Vm square and sin omega t as sin square omega t. So it will get the value of the V naught RMS. So first I'll find out the value of V naught RMS, then I'll go for the I naught RMS. Okay. So V naught RMS will be here. You can have this 1 upon 2 pi and from alpha to beta Vm square sin square omega t d omega t raised to the power 1 by 2 will be the value of V naught RMS. Now please solve this value by yourself, and I am writing down the values exactly, final value of the V naught RMS. So it will be Vm upon 2 root pi, this will be beta minus alpha plus 1 by 2, and this will be sin twice of beta minus k sin twice of alpha raised to the power 1 by 2 will be the value of the V naught RMS here. So now I naught RMS, as I have told you, I naught RMS will be having the two components. One is the steady state component and one is the transient component. So for steady state component we have the equation for during the steady state. The equation is Vs is equals to L di by dt plus RIT, right? And the solution for this is Is will come out to be Vm upon Z sin omega t minus k phi, right? Okay, and where this phi is what? Tan inverse R by Z, and this Z is under the root of R square plus omega L का whole square. ठीक है. And the transient component for transient state, for the transient component we have the equation Vs will be equals to 0 RIT plus L di by dt. So the solution for this equation will be IT will be equals to transient component will be equals to A into e raised to the power minus k R by L into T. So we'll get the value of I naught RMS by adding these two components, which is Vm upon Z sin omega t minus phi plus A into e raised to the power minus k R by L into T. Okay. So you have to find out the value of A here. So at omega t is equals to alpha, you can see the value of I naught here. What is the value of I naught at omega t is equals to alpha, which it is 0. So put I naught is equals to 0 in the put this value in this above equation, you will get 0 is equals to Vm upon Z sin alpha minus phi plus A into e raised to the power minus k R by L into T will be equals to alpha by omega. Okay. So from this equation I will find the value of A. So A will be equals to minus Vm. Okay. वही derivation अभी हमारा चल रहा है. A will be equals to minus k Vm upon Z sin alpha minus phi. और उसके बाद क्या आएगा? Exponential will come in e raised to the power R by L into exponential of R by L into alpha by omega. Okay, this is the value for the A. Now put this value of A in the previous expression, will get the value of I naught RMS, which is equals to Vm upon Z sin omega t minus phi plus A की जगह क्या आ जाएगा? ये Vm upon z sin alpha minus phi, okay, into, यहाँ पे भी एक्सपोनेंशियल है, a इंटू ई रेज़ पावर माइनस के r बाई एल इंटू टी, राइट. सो मैं यहाँ पे एक्सपोनेंशियल कंबाइंड करूँगी, r बाई एल इंटू टी है ना, तो ये हो गया एक्सपोनेंशियल ऑफ माइनस ना, तो r अल्फा ओमेगा l माइनस r बाई l इंटू टी will be the final value of I naught RMS. Now, okay, now coming to, you can take R by L as common here from here, and this will be alpha minus omega, alpha upon omega minus t, okay. So this is the RMS value of the current when load is RL, okay. Now coming to the single phase half wave rectifier with freewheeling diode. So first of all, what is freewheeling diode? So freewheeling diode is also known as the commutating diode or bypass diode. So in here you can see in the half wave we have earlier R and L load, right? For RL load with freewheeling diode means a diode, a freewheeling diode is connected in parallel with the RL, and total it makes RL load with freewheeling diode, right? So what will happen when thyristor start during the negative half cycle? Now this inductance will forward bias this thyristor and the current will flow, energy of the inductor will release through this diode instead of this thyristor, right. So the thyristor will get turned off during the negative half cycle at omega t is equals to pi, and this inductor will not force this thyristor to remain in the on state. So I'll quickly draw the waveform. So the load freewheels through this diode, that is why it is known as the freewheeling diode. The load current freewheels through this diode here. So this will be the V naught, and I can make I naught here. The value of I naught is here, and this is again V naught. Okay, during the positive cycle of the supply, thyristor will be forward bias. During the negative cycle, during the positive cycle, always thyristor is forward bias, okay, and during negative half cycle of the supply, thyristor is reverse bias in case of half wave converter, right. Thyristor is forward bias, but it will get turned on only when it is getting the firing pulses. That means it is getting the firing pulses at the gate terminal, right. So at, let's say, at omega t is equals to alpha, thyristor is getting the pulses and the load current will flow from Vs to thyristor towards the RL load and back to Vs. So at once the output voltage will start copying the tracing the supply voltage, right, because it will behave as a closed switch here. Output we are getting this, and because of the inductance load, the current will start to rise from here to here, right. At omega t is equals to pi, thyristor is reverse bias, but because of the inductance in the load, it will oppose the flow of current, and the EMF induced in it will be of opposite nature, and it will now, the energy stored in it will get for then this negative EMF, opposite EMF induced in the inductor will forward bias this thyristor, turn on this will forward bias this diode, and the current now freewheels through this diode in this direction like this, okay. So the current will freewheels, let's say, at point some beta, and but at this point also we are getting output voltage equals to 0, right. And now as the energy will released fully, inductor is again discharged, okay, fully energy is stored in the inductor is fully released at omega t is equals to, let's say, beta. Now there is no, so the output voltage as well as the output current will be 0, and again at 2 pi plus alpha thyristor start conducting till 3 pi, ठीक है. and the current again continues to rise here till pi and decays. So this is the value. So this is the current because of the thyristor, okay, and this is the current due to the freewheeling diode. Okay, so this is total, it is making the output current. Okay, so from here to here the output voltage is again 0. So for this case also average voltage will be 1 upon 2 pi alpha 2 pi Vm integration from alpha to pi Vm sin omega t. ठीक है, तो in this case the value of average voltage will be same as the case where load is R in nature only, right, and the value of RMS current here is same as previous one for the RL load, right, because it is having two components here, the transient component and the steady state component. So after solving that we can find out the value of I naught RMS. So this is it for today's lecture. I hope you understand the concept of rectifier for different loads. In the next lecture I will talk about the voltage controller and the cycloconverter. Thank you.